Section 2.6 Multiplication and Division Properties. The objective of this section is to apply the multiplication and division properties of segments and angles. In the figure below, B, C, F, and G are trisection points. If AB is equal to EF is equal to 3, what can we say about segment AD and segment EH? If segment AB is congruent to segment EF, is AD congruent to EH? In the figure at the right, line KO and ray KO and ray PS are angle bisectors. If the measure of angle JKO is equal to the measure of NPS, which is equal to 25, what can we say about the angle of JKM and NPR? If the angle of JKO is congruent to the angle NPS, is JKM congruent to NPR? The examples above illustrate a property whose proof is similar to the proof of Theorem 8. Theorem 14 states if segments or angles are congruent, their like multiples are congruent, which is the multiplication property. Also, because division is equivalent to multiplication by the reciprocal of the divisor, it's easier to prove the next theorem. Theorem 15 is if segments or angles are congruent, their divisions are congruent, which is division property. We are given that segment MP is congruent to segment NS. We are given that O is the midpoint of MP and R is the midpoint of NS, and we need to prove that MO is equal to NR. The first statement is MP is congruent to NS, which is given. O is the midpoint of MP and R is the midpoint of NS, which is all given. And then our conclusion is MO is congruent to NR. Our reason is if segments are congruent, they're like divisions. In this case, halves are congruent, which is division property. Problem 3, we are given that MK is congruent to FG and KG intersects MJ and FH. We need to prove that MJ is congruent to FH. Our proof is, the first statement is MK is congruent to FG, the second statement is KG bisects MJ and FH. Those are given. Our conclusion is MJ is congruent to FH. Our reason is if segments are congruent, their multiples, in this case in doubles, are congruent, which is multiplication property.
(2.7) Transitive and substitution properties by Kieran Beckham. Our objectives are, after starting the section, to be able to apply the transitive property of angles and segments and apply the substitution property. This is the transitive property. Suppose that angle A is congruent to angle B and angle A is congruent to angle C. Is angle B congruent to angle C? The transitive property of algebra can be used to prove this general rule. Here's theorem number 16. If angles or segments are congruent to the same angle or segment, they are congruent to each other. Transitive property. Theorem 16 can be used twice to prove the next theorem. Theorem 17. If angles or segments are congruent to congruent angles or segments, they are congruent to each other, which is also the transitive property. Here's the substitution property. In algebra, you solve for a variable such as x and then substituted the value found for that variable. Here's an example of it. If angle A is congruent to angle B, then find the measure of angle A. So as you can see, the measure of angle A is x plus 10 and the measure of angle B is 2x minus 4. So you set them equal to each other because they're congruent. And we get the value of x is x equals 14 when we get x alone. We can now substitute for 14 for x and measure of angle A to find that measure of angle A is equal to 24. Substitution property can also be applied when no variables are involved. If angle 1 is complementary to angle 2 and angle 2 is congruent to angle 3, then angle 1 is complementary to angle 3 by substitution. Here's our problem. Our given is that line FG is congruent to line KJ, and line GH is congruent to line KJ. We have to prove that segment FG is congruent to segment KJ, and segment GH is congruent to section KJ. We have to prove that line KJ bisects segment FH. So we have two givens here, that segment FG is congruent to segment KJ, and segment GH is congruent to segment KJ. So by the transitive property, we can conclude that segment FG is congruent. Segment FG is congruent to segment GH because they're both congruent to segment KJ. And we have proven now that line KJ bisects segment FH, because if a line divides a segment into two congruent segments, this means that it bisects the segment. Thank you.